Let's learn how you can do max sums using De Moivre's theorem. Okay, so let's take an example. So we know that the De Moivre's theorem says that cos theta plus I sin theta to the power of n is equal to cos n theta plus I sin n theta. Okay, now if there is a variation that it's r cos theta plus I sin theta to the power of n, you need to raise the power of r also, and then it will be cos n theta plus I sin n theta. Okay, now let's take examples, example questions. So if you have cos pi over 6 plus I sin pi over 6 to the power of 7, what you can do is you just need to bring the 7 inside. So it is like cos 7 pi over 6 plus I sin 7 pi over 6, that is equal to, you put it into the calculator, you will get minus root 3 by 2 minus 1 over 2 I. Okay, so this is a complex number. Let's take another one. Cos 2 pi over 5 plus I sin 2 pi over 5 to the power of 10 can be written as cos 20 pi over 5 plus I sin 20 pi over 5, which can be simplified as cos 4 pi plus I sin 4 pi, and put it into the calculator, you get I is equal to 1 plus 0 I. Okay, now if you have a question like z is equal to root 2 into cos pi over 3 plus I sin pi over 3, express z to the power of 4 in the form a plus bi. Okay, so what you need to do is z to the power of 4 will be equal to square root of 2 cos pi by 3 plus I sin pi by 3 to the power of 4, and using De Moivre's theorem it will become square root of 2 to the power of 4 cos 4 pi by 3 plus I sin 4 pi by 3. Then that is equal to 4 times cos 4 pi by 3 is minus 1 by 2, and sin 4 pi by 3 is minus root 3 by 2 I, and then you can simplify this as minus 2 root 3 I. So whenever you need to find something like z to the power of 2, 3 or 4, you can directly use the De Moivre's theorem and find the values out. Now let's see the question. Find the value of 1 plus I to the power of 4. Now if you get a question like this, you cannot directly change it to a z to the power of 4, because this is because it's an imaginary number. So what you can do is you can convert it into the polar form and then raise it to the power of 4. So currently z is equal to 1 plus I to the power of 4. Okay, now we can find out the r, which is modulus of z, which is equal to square root of 1 plus 1 square plus 1 square, which is equal to square root of 2. Also you can find the argument, that is tan inverse y over x, so it is 1 over 1, which is equal to pi by 4. So for the set can be written as square root of 2 cos pi over 4 plus I sin pi over 4 the whole power of 4, which can be simplified as square root of 2 to the power of 4, then cos 4 pi over 4 plus I sin 4 pi over 4, which can be further simplified as 4 cos pi plus I sin pi, which can be further simplified as minus 1 plus I times 0, that's equal to minus 4. Okay, so remember, when you have a complex number like this, you need to convert it into the polar form and then simplify it further. Okay, now let's look at another question. same type, simplify. 2 plus 2 root 3I to the power of 6. So we follow the same method here. First you find R, which is modulus of Z, which is equal to 2 square plus 2 root 3 the whole square, which can be written as root of 16, which is equal to 4. Then you find theta, which is nothing but tan inverse y over x. So y is 2 root 3 over 2, which is equal to tan inverse root 3. That is equal to 60 degree. Okay, or pi by 3. Now you can write the complex number as z is equal to 2 plus 2 root 3 to the power of 6, which can be written as 4 times cos pi by 3 plus I sine pi by 3 to the power of 6. That is equal to 4 to the power of 6 cos 6 pi by 3 plus I sine 6 pi by 3, which is equal to 4 to the power of 6 is 4096, and then 1 plus I times 0. So that is equal to 4096 plus 0I, or it is 4096.